So we hypothesized, and this was the first person to do this in my group was Wendy Bean. And what she did was she used a voltage sensitive dye to ask the question, can we find the electrical pattern memory that tells you how many heads you're supposed to have? And this is really, look, if I make the claim that the any kind of morphogenesis, so development, remodeling, regeneration, is the behavior of a collective intelligence of cells in this anatomical morphospace that we talked about, right? There's this collective intelligence, just like we are a collective intelligence of neurons. There's a collective intelligence, and it has to make decisions in this space. So by looking at the bioelectrics, we are reading the mind of this collective intelligence exactly how neuroscientists try to read the mind of animals with brains. So we looked for this electrical pattern. Sure enough, we found one. There's an electrical pattern, and you're seeing it here, that says one head, one tail. The red portion tells you one head, and the blue portion tells you one tail. Yeah.
So I'm pointing now, this is one head and this is one tail. So
yeah,
it should, make from this middle planaria, it should grow on the top head, on the bottom tail.
Exactly.
But
having seen this, we can say, okay, I'm going to rewrite this set point. I'm going to reprogram that memory into a different memory. I'm not going to touch the DNA, just like you do not touch the wires of your thermostat when you reset it. I believe that this is a goal-directed homeostatic system. I believe it's using this voltage to know what to build, and I'm simply going to rewrite it. Now, how do we rewrite it? Well, the voltage is there because of the action of these ion channels that pass potassium, sodium, chloride, protons, and so on. And so what you can do is you can, with a computer model, you can ask, which ones of these do I need to open or close in order to make the pattern be different? So literally, you're literally interacting with, we call this the bioelectric code, the idea that if we understood which channels and pumps to turn on and off, we could make that pattern be whatever we want.
So you open and close channels in order for the blue one to be to look like the red one, and then you get the two-headed worm.
Exactly.
Or the red one to look like the blue one, and then you get no head worm.
Exactly.